So we're going to talk about how electrons go around the nucleus. Right now our picture of the atom is a nucleus surrounded by electrons out here somewhere, which is not a very good model. The correct model deals with electrons being in volumes of spaces called orbitals, and these orbitals organized into energy levels. So the type of orbitals that we have are an s orbital, which is represented as a sphere. Now understand that the nucleus is always in the center. We don't normally draw it, but it's there in the center of all these drawings. And the electrons are located somewhere in the volume of this sphere moving about. That's one type of orbital, and we only ever have one s orbital per energy level. We'll talk and define energy levels in a second. The p orbital, there's 3 of those, and these start showing up at the second energy level. The s is a sublevel and a p is a sublevel. We have a px, we have a py, and we have a pz, which I really have to put an axis in to draw. This is a z, x, and y, and so my pz would look something like this. And again, the electron is located somewhere in the volume of these orbitals. I'll make these slightly different colored and different lobes on there. And so we have 3 orbitals there. And these are 3 sub-energy levels that the electrons can go in. The third type, so we have, this is the first type, the s orbital. The second type is a p. We have another type called a d orbital. And there's 5 of these d orbitals. There's 5 of them. I write it out this way because I don't want you to get confused with 5d later. So there's d orbitals, there's 5 of them, and we're not going to draw those. Some of them look like this. They're pretty complicated drawings, so we don't worry about them, but you do need to know there's 5 of them. And then finally there's the f orbitals. And if we look here, we can see a pattern. For the s orbital, we only had 1 type. For the p orbital, we had 3 types. For the d orbital, we have 5. So it should be obvious what the f orbital is, and it is 7 of them. There's 7 f orbitals anytime we get into the f orbitals. So these are the kind of volumes in space where the electron is going to go in. These are called sublevels, and these that I've numbered over here on the left are your principal energy levels. And your orbitals are going to be organized within these principal energy levels. So this row is the n equal 1, n equal 2 is this row, n equal 3 is this row, n equal 4 is this row, and we have an exception there that we'll get into later, etc. Okay? Now, there's one other rule that we wanted to define. So we have these principal energy levels over here, and we have these orbitals that I've listed out here that are sub-energy levels. And there's 1, 2, 3, 4 types of them, which 1 s orbital, 3 p orbitals, 5 different d orbitals, and 7 f orbitals. And then finally, what we have is a rule called the Pauli exclusion principle. Pauli exclusion principle, which states, I'm going to have to erase here, I rewrote, Pauli exclusion principle states that you can only put 2 electrons in an orbital. In any single orbital, you can only have 2 electrons, and they must have opposite spin. We'll get into the spin thing in the next video.